So, geoengineering the whole Earth is a little scary, and so some people have said, well, could we do things at a regional scale? And so we started looking at the idea of, since the Arctic seems to be the ecosystem that's disappearing the fastest with sea ice being lost and the southern end of Greenland possibly collapsing and so on, and the tundra melting and releasing additional carbon to the atmosphere. The question is, well, could we at least do something to prevent that and while avoiding some kind of global scale action? And this actually comes into the issue of what is a climate emergency. That, for example, Tom Wigley from the National Center of Atmospheric Research is basically, after some testing, more or less ready now to start geoengineering the Arctic, because he feels like we're already in what he would consider to be a climate emergency, in the sense that looks like we're losing a major ecosystem or biome type in the world, and also risking the loss of Greenland. And that, to him, is enough risk to want to start thinking about seriously deploying these kind of schemes. So we did some simulations where we just removed, what is this, 0.37% of incoming solar insolation, and we just took a nick out of the sunlight coming in at the highest latitude areas. And then say, okay, well, what would this do to climate? So what if we just put, and the 61 degrees extends over Alaska, 71 degrees extends basically over the Arctic Ocean. And so this one would say, let's block 25% of the sunlight over the Arctic Ocean. And then this one would say, let's block 10% of the sunlight going down to a latitude that would include Alaska and parts of Norway and Sweden, Scandinavian, Russia, northern Russia, and so on. And so this one, right? So one's taking 10% out north of 61 degrees. One's taking 25% out north of 71 degrees. So this is the same figure you saw before of the doubled CO2 warming. And then this is the effect of taking a quarter of the radiation out north of 71 degrees. And so this is basically just over the Arctic Ocean. And what you see is actually it's a bit of an overkill, that it's actually cooling now over the Arctic. So you'd probably want to do more like 21% or something like this. And you can see that the cooling effect extends down into the continents of the northern hemisphere. So you get some cooling further south. And okay, let's just do that. And so then if we do the 10% north of 61 degrees, and so 61 degrees is more or less, basically the southern end of Alaska. So you're getting, this one's going over where people are living, and so it would be more controversial. I guess both of them would be incredibly controversial. But again, here you see that for removing 10% of the radiation north of 61 degrees, you get significant cooling over, all of the northern hemisphere continents. And if we look at sea ice extent, well, I should show a more recent map, because this year I think last year with sea ice was at an all-time minimum. But basically the Arctic sea ice is getting lost faster than anybody anticipated. Also, there's some indications that the southern end of Greenland may be beginning to collapse. That's somewhat controversial. And so we looked at the sea ice in these simulations and say, could we get the sea ice to recover? And here's the control case, the sort of natural state. Here's the 2 times CO2, where you basically in this simulation just have a little patch of pretty dense sea ice, and then a lot of sort of not discontinuous sea ice. And basically, both of these 2 geoengineering cases sort of create a little bit too much sea ice. And we did a bunch of other simulations, and more or less, it's within our technological capability to make however much sea ice we want. So here's for the Arctic, the temperature changes that we predicted using, what our model predicted. And so here's the warming over the Arctic for this model, which is, again, the National Center for Atmospheric Research model. For the Arctic for a doubling of CO2, and so we sort of overdid it a little bit with this 25% north of 71 degrees and underdid it a little with the 10% north of 61 degrees. But basically, you could see that by turning the knobs, you could get the Arctic to be 0 temperature change. An interesting thing is that you don't do very much to reduce Arctic precipitation. And that's because, remember when we geoengineered the whole world, precipitation reduced a little bit or somewhat, that basically at a point-by-point basis there was no statistical change in precipitation. When we do the Arctic only, there's still lots more precipitation in the Arctic. And that's because the high latitude precipitation is driven by evaporation in lower latitudes and then that water vapor transport to the high latitudes. And by geoengineering the Arctic, you're not doing anything to reduce the evaporation in equatorial regions. And so the result is that you get much more snow because now you've cooled things off, but you're getting more or less the same amount of precipitation. And so you've got a much snowier Arctic. And so some people would say, oh, okay, well, this is imperfect climate modification. And now other people like Mike McCracken have said, well, maybe this is what you want to do, because if you're worried about Greenland collapsing, what you want to do is put as much snow on top of Greenland as possible. And so geoengineering the Arctic would do it. Another thing that's been raised is this issue of, well, won't this destroy the ozone layer if you put a bunch of particles in the stratosphere? And certainly this needs more attention. But the first thing we can see is what happened after Mount Pinatubo. And so this is 1991, Mount Pinatubo going off. Now, just so you see the scale here, this is a measure of the amount of ozone in the atmosphere. And so this is 280 Dobson units, 290, 300. And so the estimates are that there was something like a 3% reduction in total ozone after Mount Pinatubo. But it's hard to say what's due to shifts in, the particles from Mount Pinatubo only stayed there for a year or two, and there's problems of intercalibrating units, different satellites and so on. But basically, while there might be a couple of % reduction in stratospheric ozone, that it wasn't a major effect. Furthermore, the destruction of the ozone depends on having chlorine in the stratosphere from CFCs. And because of the Montreal protocols and the reduction in CFC use, the chlorine in the stratosphere is decreasing. And by mid-century, it's thought that there'll be so little chlorine in the stratosphere that even if we threw a bunch of particles in, it would have virtually no detectable effect on ozone. And so again, well, this is a research issue. There's no evidence that there would be any major destruction of the ozone layer or anything like that. But these are all preliminary results.